The seafood on your plate doesn't just feed you, it's shaping the future of our planet. But at what cost? Aquaculture, the farming of aquatic species, now provides over half of the fish we eat worldwide. But this rapid growth comes with challenges. It can strain ecosystems, deplete biodiversity, and worsen climate change through high resource use and pollution. That's the question driving new research at the University of British Columbia in Canada. At UBC's Institute for the Oceans and Fisheries, PhD student Aaliyah Wong explores how aquaculture species can balance these goals. Her work offers a new perspective on sustainable farming.
The UN Sustainable Development Goals include food, climate change, and biodiversity as 3 of the 16 major goals. These 3 different goals are highly interlinked. If you're only looking at one at a time, you might be missing a bigger part of the picture.
One solution Aaliyah proposed is a traits-based approach. This method evaluates species by their biological and ecological characteristics to determine their sustainability potential.
What I am calling biological and ecological traits are essentially characteristics of species that are related to that species' survival, reproduction, and how species interact with their environment. We sought to uncover what traits of aquaculture species are associated with each of these 3 goals. If you have a carnivorous species like salmon that's at the top of the food chain, then you need to source wild fish to feed your salmon. So not only does that detract from wild biodiversity, it contributes to climate change because of all the fuel needed to go get those fish. This can also impact food security because you're taking fish from an environment where it could be consumed by local people, and then you're funneling it into feeding salmon.
Through her research, Aaliyah found that lower trophic species such as seaweeds and mollusks are more sustainable.
And we're seeing seaweeds and mollusks have consistently higher food, climate, and biodiversity scores. How fast a species grows, so a trait like maximum body size, so where does your species lie on a food chain, actually relates to each of the 3 different goals.
She also highlighted integrated multi-trophic aquaculture, otherwise known as IMTA, as a promising solution. IMTA systems use a symbiotic approach, meaning farming species like seaweeds, mollusks, and fish together. Waste from one species becomes a resource for another, mimicking natural ecosystems.
In addition to which species we can be farming, there's this added layer of how can we be farming these species. An integrated multi-trophic aquaculture system is bringing together species that might have trade-offs, and that is sort of synergizing the different, or reducing the trade-offs that we're seeing in monoculture aquaculture.
Rethinking aquaculture isn't just a choice, it's a necessity. Climate change, population growth, and biodiversity loss demand solutions that balance sustainability and economics.
It's not as simple as never eat salmon or only eat seaweed, but I think that in a world where these social and cultural things have been worked through, that is a great way to utilize your consumer power, eating species and driving demand for species that have lower environmental impacts. And on the policy side, emphasize these lower trophic species. And we need to consider as well that there are trade-offs between achieving any one of these food, climate, and biodiversity goals.
The seafood we farm today will shape the planet we leave for future generations. By rethinking aquaculture, we can protect our oceans, support communities, and ensure food security for years to come.